Hello, challengers. We are here again in this weekly live that happens every Tuesday at 10 p.m. London time. And today we're going to be talking about data structures because when you're doing an interview, you're going to have a code challenge. And in this code challenge, you're going to have to solve algorithms and you're going to have to know about data structures. So, data structures is a vast topic. So obviously, I won't be able to give you all the details about data structures, but I'm gonna be able to give you an introduction about the most important data structures. You're gonna get the mind map at the end of the presentation. So stay until the end so that you get the mind map, and I'm gonna share the code with you later as well. So I'm gonna send the code to you by email, okay? But just keep in mind, data structures is very important because if you don't know about the data structures, it's going to be very hard to solve code challenges and to pass in interviews. The first thing before solving algorithms is to know the data structure you're working with. Otherwise, it's going to be very hard even to solve the easy algorithms. So that's the first thing. Today, we're going to be talking about string structure, and knowing those data structures will make all the difference when you're solving the easy or medium algorithms. Okay, so without further ado, let's start exploring the string data structure. So what are the main fundamentals of this data structure? Firstly, a string is a sequence of characters started as an array. If you notice, after Java 9, so we used to have an array of char, right? But now, after Java 9, for performance reasons, if you open the string class, you're going to notice that it's not an array of char anymore that stores the data for a string. Now it is an array of byte. So what are the properties? So it's important to remember that a string in Java is immutable, right? What does that mean? It means that every time you create a string, you can't change the object in the memory heap. Unless the garbage collector notices that the string is useless and it cleans out from the memory, the string will be there, which means that if you create another variable pointing to the same string value, you won't be creating another object because it's going to be in the object pool, right? So these are very important concepts to know about strings in Java. It starts with 0, the index, right? Because behind the scenes, a string is an array. And it also has a fixed length after creation. So after you create a string, it's that size, because if it's an array behind the scenes, an array, it's a fixed size. Once you create this array, you can't change the size of it, right? So that's an important concept to remember about array. Hope you guys can see it. So what are the operations of a string? So one important operation of a string is concatenation, right? And this is what we learn in the first days when we are in college. There is also substring extraction, which means that we can extract substring from a string. We can access a character. And that's very important to remember when you're doing a coding challenge, because there are some coding challenge you have to reverse string, or that you have to count strings, or that you have to check if there is repeated strings. So knowing that a string behind the scenes is actually an array of character or an array of a byte, then you can manipulate whatever is the character in this string, right? You can also search a specific character or the index of this string and do comparison as well. And okay, so what's the time complexity of a string? So to access a string, it's O1 because it's an array. To search a character, you have to iterate over the array and check if that character, if that value is the one you want. And for concatenation, it's O(n) plus m. And what about memory? So per character, we store 2 bytes in the memory. And there is an overhead for metadata as well. And okay, what are the common methods? Length. So we need to know those methods because they're very useful for algorithms. Char add. This is very useful when we are doing algorithms. So like in most string algorithms, we're going to be using this method. So basically this char add method gives us access to every char in the string. We can create a substring as well. We can use the equals and compare to methods. They are given for free, right? So we have those methods already implemented in the string class. We have the two lowercase and two uppercase methods. And implementation details in Java. It's important to remember that in Java, the string has a string pool. So which means that if you create a string with the same value, you're going to be pointing to the same place in memory. There is an edge case scenario here that I can show you. You probably saw it if you already studied for the certification. But there is an edge case scenario where even if you create two strings with the same value, they will be different objects in the memory heap. And I'm going to show you that. And for a string builder, it's very important when you're concatenating strings because, you know, if you are concatenating strings with a string object, you're going to create 1 million objects in the memory heap. And that's not performant at all, right? You might even create a Stack Overflow error when you do several concatenations. So when you're concatenating several strings, it's better to use string builder, right? And you're going to increase performance a lot. And what are the use cases for a string? So many. We work with strings all the time. Text processing, data representation, communication protocols. And how do we represent a string in the computer? One other key for doing algorithms is knowing that a string actually corresponds, not a string, a character actually corresponds to a number in the ASCII table or Unicode, right? So it's very important to remember that because in many algorithms you're going to have to use this code. You're going to have to do some calculations. And I'm going to show you some examples, some code examples with string. And it's super useful to know that. Okay, and what are the main values from the ASCII table? So the main values from the ASCII table, if you see here, from 0 to 31 are control characters, right? 32 is space. From 48 to 57 are the digits from 0 to 9. 65 to 90, A to Z uppercase. 97 to 122, lowercase a to Z. And, you know, there is of those points. There is a lot more, right? And you have also to notice that Unicode is a superset of ASCII. And the Unicode was designed to use other characters from Asia and other countries. So like it includes over 150K characters from all world languages and symbol systems. In the latest Java languages, we are not using ASCII anymore. We are using Unicode so that we have access to more characters in the world, right? So those are important details from the string. Now, let me show some algorithm. So this is a simple algorithm, and the problem is to determine if a string is a rotation of another. For example, there are the same characters here. We receive two strings in this method. Yeah, so those algorithms are not difficult, right? You just need to, like if you know the basics of data structures, like you can easily solve them. So firstly here, you're going to compare here some edge case scenarios, and then you're going to check the length. And, you know, here's the char@, method. And this is a very important method. And basically, like this is a ON2 complexity, right? So the performance is horrible because, you know, we're going to go through each character, right? And we're going to compare this character with each character from the string 2. And if all the characters match, then we return true, right? Let's see here some concepts from a string. Notice here that this string is being, like, when we create this string like that, we are creating one object in the memory heap. And this variable is pointing to this object in the memory heap. And what happens is that when this object is inserted in the string pool, this variable will be pointed to the same object. But there is a weird edge case scenario where if you force the creation of a new string, even with the same value, a new object in the memory heap will be created. It will just ignore the memory heap. So here we have two objects, three variables. Strings are immutable, right? Here we have two objects, right? Duke and Java. And for string compare, we will, for example, here we have two objects. So S1 and S2 are pointing to the same object. Different variables pointing to the same object. But when we check here if S1 is equals to S3, it's going to be true. Why? Because the value of this string is the same. Even though S3 and S1 are different objects, they are pointing to different objects, they have the same content. So it's going to be true. And here we have the most important methods for string: length, chart, index of, contains, to lowercase, replace, and we have concatenation. String builder, if you want to concatenate many strings, it's better to use it because then you won't be creating 1 million objects in the memory heap. And we also have here this method that basically will force a string to the string pool. And we also have this method here, string splitting. So if you want to split the string by a comma, you just use this split method and then you get an array back, right? So those are the most important methods that you have to remember when you're doing an algorithm. There is this algorithm of reverse words as well. Let me see here. Compact mode. Okay, so this algorithm, you reverse the string. You receive a string here, and you're going to basically split the string in two words. You're going to use that split method. And almost any programming language, you're going to find this method. Like this is a very simple method from a string because a string behind the scenes is an array. I'm going to show you here. So if you go to the string class, you see that a string implements comparable, which means that we can use the equals method. And what is the value of a string? It's an array of bytes. So it's important to know because, this is the data structure, right? So obviously there are more complicated methods here, but that's the value of knowing the fundamentals, because if you know that a string behind the scene is an array, then you can manipulate the characters, you can manipulate what is inside the string. Like if you don't know that a string is an array behind the scenes, then you don't even know how to access the characters, right? So as you can see here, UTF-16, so Unicode. So there are many important concepts here. Okay, so let's go back. So we create a string builder and we start the array from the end of the array. We get the length of the string array, and then we append each character to this result variable, and that's it, right? We will reverse each word from the string. Now imagine if you didn't know that a string wasn't an array behind the scenes. It would have been possible to solve that. That's why it's important to know the data structure before solving algorithms. Because, for example, if you don't know a string, if you don't know an array, if you don't know key value, the structure, it's going to be difficult to solve. What about the palindrome challenge? Let's go here. So what is a palindrome? It's basically, so we're going to determine if a string reads the same forward and backward. So this is the same, right? So here we handle some edge cases. So if it's no, then we return true, right? So the first thing we do here is that we remove non-alphanumeric characters and convert all of them to lowercase. And then we follow the pattern here, which is very common in algorithms, encoding algorithms questions. So basically we create the two-pointer approach. So we create a pointer to the left and the other pointer to the right. And we put those variables into a while looping. First, we clean the string to see if there is like a number, right? And we transform all of those strings into lowercase. And then basically we check here if the character from the left are different from the character from the right. It's not a palindrome, so it's going to be false. And then we move the pointer from the left, like so we go one position ahead and the right pointer, we go backwards, right? And if we don't return false here, it means that it is a palindrome, right? If all the characters are the same, then it's a palindrome, right? Okay, let's go to the other one. So this algorithm is a simple one to find the first character string that doesn't repeat. So basically we have to run through the whole string, and then in the end we see what is the first one that doesn't repeat. So here we receive a string and we have this char count. Basically, we're gonna add each character here, right? And yeah, we're gonna count all the characters that we find here. So every time we find a different character, we're gonna sum, right? So, and then in the end, we check what is the first character that has only one character. So that's pretty much it. This one is very simple. Let's see another one. It's anagrams. What is the problem? Determine if two strings use exactly the same characters with the same frequency. So basically, we have the same letters here. So this is an anagram, right? It's A, B, C, Z, B, C, A, Z. So this is an anagram. So in every algorithm, when you're doing an interview, you always check for edge case scenario. Always ask the interviewer, hey, can I receive a null value here? Or can I receive a string with different length? So always ask for edge case scenarios because, you know, if the interviewer says, no, a null value, actually, yeah, if the interviewer says to you, you can receive a null value, then you do a quick check already to handle the edge case scenarios. Like if you don't ask about those edge case scenarios, it could be a red flag during the interview and they could reject you just because you didn't ask for the edge case scenario. Okay, and what do we do later? So we convert to lowercase, right? So that we can do the comparison. And here in this algorithm, we use the ASCII table, right? So yeah, it is good to practice, definitely. Yeah. So as we were discussing on this string data structure, the string data structure is based on the ASCII table, which means that each character from a string represents a number in the computer. And from where do we get those numbers from? So a pattern was created, which is the ASCII table, right? And with the ASCII table, like a character is actually a number. So we are creating an array of 26 because we have 26 letters in the alphabet, right? So what we are doing here? So basically we are subtracting the character by A, and we are also adding 1 to each character, and then we are subtracting to each character here. So what we are doing, so let's, to make it very clear, let's debug that. So we have F8 not working anymore. That's great. Okay, let's see. Okay, great. Let's see. So we have here two strings, right? We have string 1 and string 2, and we are creating an array of 26 of the length of 26. And we get here the length of the first string. And if you see here, the first letter here is A corresponds to 97 in the ASCII table, right? So if you go here to Wikipedia, this is the ASCII table, and this is how the computer will represent a letter, right? So if you can see here, 97 is A, right? In Unicode and ASCII. So let's see here, 97. So this is an important detail to notice, because a string behind the scene is an array of bytes, and each character is represented by a number in the ASCII table or Unicode table. And those numbers, in some algorithms, we're going to have to manipulate those numbers, right? And basically, if we get the character of A here, we're going to subtract with A, right? Which is 97 minus 97 is 0, right? So basically, we're going to get the number of 1 here. So I'm going to show you. So in this char count, we have the number 1, which means that we have the letter A, right? And now we have on string 2, we have the letter B, 98. 98 minus 97, it's 1, right? So it's going to be 1 minus minus, right? So if we see here, it's going to be -1, right? And now we have the letter B, right? Now it's going to be 0 here. This is a kind of a weird algorithm, but it works very well, right? So, and here it's C. So the third element here will be negative, will be -1. But basically, the logic of this algorithm is that all the elements, all the letters in this array will be 0. If all of them are 0, it means that the strings are equals, right? It means that this is an anagram, right? And the good thing about this algorithm is that it's ON, right? So this is ON. And then we keep going. You see, it's all 0 here. And now, since we are on letter Z, you can see that the character 26, which is the last one, we have now the number 1. But then on string 2, we're going to subtract, right? So basically, we get this chart here. Let's just remove that. So it's 122. 122 minus A, it's going to be 26, right? 26 because it's a position in the array. And then it's minus minus. And when I do this minus, this number 1 will be 0. Therefore, they're going to be equals. Therefore, it's a palindrome. So those algorithms are very good to practice. Great. Thank you so much, everyone. Thank you so much, Abishal, Guilherme, Ahmed, Uma. Invest in your career and doing your best. So in the next slide, I'll probably go over only arrays because as you could see here, like only one this structure takes some time. So it's not that simple, right? And if I want to give you some code examples as well, I need to go a little bit deeper. So from this weekly live, I feel that it's better to go one data structure at a time, so that I can also go more deeply into it, right? So it's better for you as well to review all of them because then you're going to be better prepared for the interviews. Okay, so guys, thank you so much. And I'll see you hopefully on next Tuesday at 10 p.m. London time. And congratulations on being here, investing in your career, right? That's a good thing. And that's it. That's pretty much it. I'll see you next Tuesday then at 10 p.m. London time, okay? So